So I'm happy to have Ben Nason with us. Broadcast Tools, based out there in Washington State, and they make all kinds of little goodies and big goodies, things that help us do our jobs. And so, Ben, I asked you to talk a little bit about controlling audio and systems and what you've got in mind for us.
Yes. Well, thank you, Barry. Thanks for having me on. I want to say long-time listener, first-time caller.
Well, we're glad you're here and we welcome you to come back.
Yeah, I mostly watch on YouTube, so it's fun to actually participate this time around. And I see some familiar names and faces. Um, as Barry said, I'm with Broadcast Tools, and we make problem-solving tools for radio, but also for television, but mostly in the area of audio and remote control, GPIO, things of that nature. So we're going to talk about site remote controls and some new developments in audio switchers and the different products we have available. I'm not going to talk about all of them, but we'll cover some bases.
All right. Where should we start?
All right. Well, let's start by sharing my screen here, and we'll go through the slides.
There you are.
Okay.
Excellent.
Okay. Yes. Well, again, thanks for having me on. What's new with Broadcast Tools? 36 years in business. I want to tell you guys I'm 38 years old, so I haven't been there the entire way. But I joined Broadcast Tools in 2011. I have a background in college and community radio engineering, and I help out with tech support and testing. A little bit more about Broadcast Tools. Founded in 1989 by our owner and president, CEO, chief designer, Don Wingett. It's a veteran-owned business. We're based out of Washington State, Cedar Woolley, if you've ever been there. It's a nice small town. Um, our products are designed, manufactured, and supported here in Washington State. That means our circuit boards are assembled here in the USA. Our metal fabrication is done here in the USA, and our final testing and assembly is done in Cedar Woolley. So, well, what do we have? Let's talk about site remote controls. So this is our current lineup of remote controls. We have four of them, and they're sort of separated into two lines, the Site Sentinel line and the WVRC line. The Site Sentinel remote controls are web interface only, whereas the WVRC remote controls have a web interface as well as a telephone control interface for that extra redundancy. We start off with the Site Sentinel 4, which is a 4-channel device, and then go up to Site Sentinel 16 G2, which is a 16-channel device. When we talk about channel counts, in this case, if you have a 4-channel unit with the Site Sentinel 4, you're getting 4 metering inputs, 4 status inputs, 4 relay outputs. And from there, sort of the numbers expand based on model. Some of the basic features you're going to find on all 4 of those products are an HTML5 web interface for control, SNMP support, so we can do set, get, and traps. So if you have an SNMP system, which a lot of the larger broadcasters do, you can integrate right into your existing monitoring system. SMTP, very important feature. You need to be able to get alarms out to people. So we have SMTP for alarm notification and logging. As I said, relay outputs, starting with 4 going up to 32 on the Site Sentinel 16. Opto-isolated status inputs to monitor contact closures and other outputs. Analog metering voltage inputs. All of our products go from 0 to plus 10 volts DC to monitor whatever voltage you might have coming from a transmitter or other device. Silent sense inputs. I'll say if you have any questions, you can interrupt me. Otherwise, I'm just going to roll through here. Silent sensors are a big part of our business. We do a lot of different variations on that. And so, of course, our remote controls have silent sense capability. Power failure input. Simply put, you have an input for a DC coaxial jack, and you can power that from your non-backed up power to get an idea of what's going on there. And then temperature monitoring. So all of our remote controls have the option for at least one channel of temperature monitoring and some more. Our latest update is the Site Sentinel 16 G2, and here it is in all its glory. See the front and the back right there. Um, Site Sentinel 16 is not a new product for us. It's been on the market for a good while now. So we basically did an incremental update to modernize some things and allow us to add some pretty cool new features in the future. Um, what does it look like? Well, that's what it looks like on the outside. Here's how you would typically access it from your web browser. You have the HTML5 interface, login page, log in, you get to the monitor control page where you have everything you need all in one spot. So you can see we have our metering inputs, relay control and status, temperature, silence sensor, status inputs, um, virtual channels as well, which allows us to take those existing metering values, two of them, and apply a constant. So you can do some basic calculations in direct power and things of that nature. Um, you can see we have the date and time there. We use NTP to keep the clock up to date. This unit also has a battery backed up real-time clock in case we lose internet or there's a power cycle, it will still know what the day and time is. And a lot of really cool features. It has an event scheduler, so you can do 100 events. Most commonly, we see that used for AM stations that might have power changes or other things of that nature. I didn't get a screenshot of that, but you can get the idea. We also have macros on the Site Sentinel 16. Scheduler is across the board on all the remote controls. Macros are on the Site Sentinel 16 and the WVRCs, but not on the Site Sentinel 4 right now. One of my favorite features on our remote controls is what we call the event action sequencer. And so this is a screenshot of the relay IO setup page on the Site Sentinel 16. You'll see at the bottom there, we have what's called the event action sequencer. And it's a really easy way to control the relays based on alarms on the device. And so you can see in the example here, we have the event action sequencer enabled. And when meter one is in high alarm, we're going to delay for 2 seconds and then engage the relay for 5 seconds. So you can go through those drop downs and you could change that so that, okay, I want the temperature input on high alarm, trigger the relay. The delay time can be set to 0, so there's no delay. The engage time, you can set it to however many seconds you want. But in some cases, you don't want a momentary closure. You'd like a closure for the duration of the alarm event. And we can do that just by setting the engage time to 0 seconds. And that will keep the relay active for the duration of the alarm. So, that's sort of the basics of the Site Sentinel 16. I don't know if you guys have any questions about remote controls, but I think we've got a pretty good lineup. So we'll go on to something very new, which is the Temperature Sentinel 4 G2. So this is a sneak peek. It's not shipping yet. This is what it's going to look like. And there's the front, there's the back. And it is a temperature monitoring device with a web interface. And so you can see we have 3.5 millimeter connectors as well as terminal block connectors. And those are for your temperature probes. If you're familiar with our remote controls, we use a 3.5 millimeter connector for our external temperature probe. And so this supports that. The terminal block connectors there are so you can add third-party probes. And so this product supports the one-wire digital temperature sensor format. And so you don't just have to buy the probe from us. You can bring your own probe as long as it's one of the supported ones and monitor temperature at your site. And so this is what the web interface looks like currently. And of course, it supports the standard features, email alarms, logging, and then SNMP. And so we think that's going to be a pretty good application. If you just need to add temperature monitoring to a site, this box will do it very affordably. And via SNMP or whatever other method you want. Now, in addition to the temperature probe inputs, four of them, it has a relay output. It has a similar event action sequencer functionality where you can program that relay to close based on temperature values or just control it from the web interface as you see on this page. And then it has a status input. So if you've got another device on site you want to monitor, you can wire it in here and also get notification on that. And here's what the setup page for a temperature channel looks like. You can set your alarms high and low, hysteresis, and relay action. So yeah, that's basically what I wanted to talk about as far as site control. So we have temperature sentinel, sort of run through web interface, SNMP, SMTP, relay output, opto-isolated temperature probes, one-wire sensors. So let's go on to switchers. I think a lot of people know us for our switchers. We've been making them since the beginning, as far as I can tell. And we have a few different areas of switching. So we're going to go through some of those areas, um, starting with matrix switchers for broadcast automation. This is a switcher where you are able to take multiple audio sources and send them to multiple outputs. Typically, we have three modes that you can do that in: interlock mode, where only one input can go to an output at a time, or a mix mode, where you can have multiple inputs going to an output, and then overlap, which is kind of a restricted mix mode, where you can only have two inputs going to an output at a time. In these matrix switchers, we use active audio circuitry. So you have input level attenuation trimmers and then output gain controls. So you can tweak the audio levels as needed. And then we have multiple forms of control. So we have a front panel interface where you can use buttons to control it. We have a serial interface for control. You can configure it to be controlled via contact closure. And then with our newer models, we're adding Ethernet. So you can forego RS-232 serial and go directly on the network using TCP or UDP commands. We also have status outputs, front panel LEDs, serial status, relay contact closures, and open collectors often. It wouldn't be a broadcast tools product without silent sensors. So we often put output silent sensors that will give you notification and contact closure. And all of this works with your automation software of choice. So we're as agnostic as we can be about that, but we welcome everyone to support our products. Probably our most well-known switcher is the ACS 8.2 Plus, and it's had a number of predecessors, starting in 1996 with the 8X2, 1998 with the SS 8.2, 2002 with the original ACS 8.2, and then 2006 with the ACS 8.2 Plus, which we are still selling. So what's next? Well, we do have a new model that is shipping and was announced last year, and that's the ACS 8.4 G2. So let's talk a little bit about that. Here's what it looks like on the front. You can see those front panel controls I was talking about. Of course, we also have a headphone amplifier output and level meters. There's a monitor select button, so you can switch through and listen to all four outputs as you need. Look at the back here, and you can see something new for the ACSs, and that is RJ45 audio connectors. So gone are the 5-position terminal block connectors, and now we have RJ45 on this product, which saves some space and oftentimes makes it easier to do a new installation, I would say. On the back there, we also have that terminal block connector on a double stack. That's for the relay outputs and the PIP trigger inputs. And you can see we have Ethernet for the TCP UDP control and RJ11, which is what we use for RS-232 serial. So how does that compare to the ACS 8.2 Plus? It has 8 inputs and 4 outputs. ACS 8.2, of course, has 2. ACS 8.2 Plus has terminal block connectors for audio. 8.4, we go to RJ45. Same number of trigger inputs. We add more relay outputs on the 8.4 and Ethernet, and all at the same price. So we think it's a pretty good deal. Another thing that I didn't add there, one of the features we've added in firmware is the ability for the 8.4 to emulate the 8.2's serial command set. So you can basically change a setting on the device, and from a control standpoint, the automation software won't know the difference. It'll present itself as an 8.2. You still have control of the additional outputs via discrete commands, but sort of a problem solver for those situations where you might not have support for the new switcher in your software yet. Yeah, so that's what's new in matrix switchers for us. Let's go on to more switchers. So another big category of switchers for us are what I call passive switcher routers. And so unlike the ACS, which is an active switcher, a passive switcher uses relay contacts to switch audio. And so we're not doing any level adjustment or anything of that nature. We're just routing the audio. Because we are routing the audio, it's bidirectional. And so that's why we say switcher and router. So the most common application is switcher, source selection, where you have an input going to an output. In a router configuration, you'd be taking your audio source and putting it into what we would normally call the output of the switcher. But as I said, because we're using relays, that output can then be routed to the input, essentially. To do this, we're using mechanical relays. We're going to talk a little bit about the benefit of the specific relays we use now, which are mechanically latching relays. And as always, with these switchers, we have front panel controls, serial control, and contact closure control. LED indicators on the front panel, either relays or open collectors for status, and a lot of applications, satellite switching, studio switching, source selection for AOIP, which we'll take a look at, and STL switching. We see these switchers used for STLs and for N+1 systems all the time. We also have a piece of software I want to show you, which is a Windows application called NetSwitch 3. It's a free app. It works with almost all of our switchers right now, and it gives you a quick and easy way to control a switcher either via serial or over the network from a PC. So here's sort of the lineup of passive switchers: SS2.1 MLR, SS4.1 MLR, SS6.1 MLR BNC, and the SS8.1 MLR. Now, it can get kind of overwhelming with all the names and variations, but we'll go into that in a little more detail. Here's that example I was telling you about. I pulled this one from Radio World up in Canada, Pattison Media, using a couple of 4.1s to do source selection for a tie-line codec. And I must say, it's one of my favorite things is to see pictures of equipment out in the wild. That's one of my favorite things to see. So here's sort of the grid of what we're talking about as far as I/O choices and channel counts. So within the world of passive switchers, we have terminal block versions, we have RJ versions, we have BNC versions, and then we have at least one XLR version. And so when we talk about terminal block versions, we're talking about those little green connectors, 3.81 millimeter pitch terminal block connectors. Those switchers we typically see used for analog stereo audio or AES-CBU digital. And so we have three switchers there, the SS2.1, 4.1, and 8.1 term. More recently, we came out with RJ45 versions of those. So we have 2.1, 4.1, and 8.1 RJ45s. And then another switcher called the Universal 4.1, which adds some extra features. We also have some BNC switchers, 2.1 and 6.1 BNC. And of course, with a BNC connector, you're typically not doing analog stereo unless it's in the composite baseband MPX world. And we can also, of course, do digital audio on BNCs. The Universal 4.1 is a pretty cool product in that it has RJ45 connectors and XLR connectors hooked up in parallel. So you can kind of mix and match your I/O. It also has a web interface, so it's a pretty handy device. Let's talk a little bit about relays. So, pretty cool quote here from Richard Feynman. Everything is interesting if you go into it deeply enough. And we're not going to go really deeply, but let's just talk a little bit about relays. Found this nice picture from 1956, great illustration of a relay from yesteryear. Of course, being used for telephony, because that's sort of an area where, if you look back at the history of broadcast, we've borrowed a lot from the industry and continue to do so. And I will say, though, that the relays we use nowadays are not these relays. So relay technology has come a long way since then. And this is an example of more what we're used to nowadays, which are modern signal relays. They're sealed, they're miniaturized, they're using silver alloy and gold. They have a bifurcated crossbar and they are self-cleaning. So we really like these relays. We use them all over the place, and they uh, they do a great job. Here's sort of an example of the typical relay we use, which is a non-latching Form C relay, two Form Cs, and nice little diagram illustration of what it does. But it says non-latching. Well, what about latching? So, these audio switchers, the MLR audio switchers, we're using a latching relay. And what a latching relay is a relay that you can set or reset. And so, the normal relay, you have to keep it energized for it to be in that state. With a latching relay, you just have to essentially pulse it on or off, and then it will remember that state even if it loses power, which is useful for broadcast applications. Um, if you have a power situation or something, you will know exactly where the switcher is because it will be in that last state that it was latched to. Web control, well, computer control, I should say. So I mentioned NetSwitch. So here's what NetSwitch looks like controlling the SS6.1 MLR BNC, our 6-channel BNC switcher. It's a Windows app. You can get it on our website. Just go to broadcasttools.com/download, install it. And here's an example of it connected to the 6.1 over the network. And you can see it shows the current switch position. And you can just click through to control it remotely. But what about the web? So that example with NetSwitch, you were controlling it over the network. So you can do that over the web, but you're doing it from a Windows application. Well, what if you don't want a Windows application? Some people don't, some people do. We have a solution for you, web-enabled switchers. So we talked a little bit about the Universal 4.1 MLR already, but we have some more, both for AES and for analog audio. So here's the lineup. Audio Sentinel Plus WebRJ is a very popular one for us. It's a 2x1 analog stereo switcher, and it's a silent sensor primarily. And what that means is that on both inputs, we do silent sense, and it's able to do automatic backup switching. So if silence is detected on input 1, you can set a delay time and then have it automatically fail over to input 2. And then when audio returns to input 1, you can automatically switch back. During that process, it's going to provide you with contact closures to notify you. It'll also send an email. It also does SNMP. One of the newest switchers in the lineup here is the AES Switcher Sentinel XLR. And so as the name implies, AES, it's a digital audio switcher. It's a 4x1. And let's see some more about that. Oh, sorry. Another real world example. This is for the Audio Sentinel, but in Leipzig, Germany, they installed a bunch of the Audio Sentinels for RegioCast. And as I said, I just love to see the real world installations. So what features are we getting with a web-enabled switcher? HTML5 web browser interface, alarm logging, email notification via email, and then email to SMS, which there's been some changes in that area, but it's certainly still possible and something we see folks doing. SNMP, and then programmable relay outputs. So a lot of these switchers have programmable relay outputs where you can determine what condition would cause a relay to close. As I said, here's a new one for us. It's the AES Switcher Sentinel XLR. It's got XLR I/O, so you've got four AES inputs on XLR and one AES output. You can do headphone audio monitoring on the front panel there, and you can also control it via contact closure if you'd like. Here's what the web interface looks like. We get metering for that output audio. It's got output silence detection. We can use that output silence detection to do rules-based automatic switching. So we can say if input one is silent, switch to input two, for example. And then if input two is silent, we could have it switch back to input one based on a rule, or we could have it go on to input three, or whatever combination you'd like. So that's kind of the rundown of web-enabled switchers from Broadcast Tools. But we've talked about matrix switchers. We've talked about web-enabled switchers. Well, what else is there? We also have some more specialized switchers. And one of the areas we specialize in is EAS insertion, especially in this day and age where there's been some supply chain constraints. A lot of times it makes sense to take an existing EAS box and add more stations to it. And a lot of them support it. Sage NDEC does, and the DAS deck does, as far as I know. And so we have three products in that area, starting with the MSRP3, which is a three-station analog switcher, and then the MSRP3 Net, which is a variant of that, which has, instead of serial control, network control, and then the MSRP3 AES, which is the digital audio version. So, as I said, add stations to the Sage NDEC or DAS deck. For those of you who don't know, Broadcast Tools was the OEM for the original Sage Harris RP2, also known as the MSRP3. So this is an area we've been in before, but we saw that there was sort of a need for that product again, and so we came out with these MSRP3 boxes. Typically, you see these controlled via RS-232 serial from the NDEC box. It doesn't have to be RS-232. We also support contact closures. And then with the net version, instead of serial, we have TCP UDP Ethernet. The latest firmware update from Sage for their NDEC added support for that. So you can forego the serial connection and control over the network. And then with the AES version of the product, we have enough room on the back to do serial and Ethernet. So we added both. Another cool feature of the AES version is it has a built-in analog to digital converter. So here's the MSRP3 AES front and back. You can see we're using RJ45s for the station audio. And so you're basically looping through your stations using those RJ45 connectors. We have three stations there. The whole purpose of an EAS insertion switcher is basically to take that single alert audio source and distribute it to multiple stations. So we have an alert audio input. On the MSRP3 AES, by default, that's an AES input. So you can get your digital audio out from your encoder. If there's an application where you can't get AES audio, you can't get digital audio, it has a built-in analog to digital converter. So we can use that little front panel switch it into the ADC mode. Then all of a sudden, the input is now an analog mono audio input. And so it takes that analog audio, converts it to AES, and then it's ready for distribution through the switching built in to the device. What else is going on in specialized switchers? So here's a sneak peek. This is a product we announced at NAB this year. It's not quite shipping yet, but we think it's pretty cool. So let me tell you more about it. The Alert Sentinel 2 is a two-station audio insertion switcher. So like the MSRP, audio insertion. But what about applications that aren't really right for EAS? So there's been a lot of great discussion about EAS on the BDR and the future of it. But lots still unknown there. But we do know that we want to be able to get people on the air. And Alert Sentinel, that's the idea. It has two stations and a number of audio sources. It has an MP3 player as one of the audio sources. So it's got an SD card for storage. So you can put pre-recorded messages on it and trigger them. It also has a telephone interface. We've had a number of products over the years that would allow you to dial in and get audio on the air. And so this is part of our idea of doing that all in one box. So it does the switching and the telephone audio. So it's got a hybrid and it has DTMF control commands. For those applications where a phone line is not practical, it also has an external audio input. So you could hook it up to a codec or a computer and control it either via DTMF or via local contact closure. The applications we're thinking about for this are like remote weather alerts, remote broadcasts, even live sports. We've seen that done with our STA, and we think the Audio Sentinel will be even better for that. Alert Sentinel, excuse me. Here's what the back looks like. So again, we have RJ45 for station in and out, but in this case, we also have terminal block connectors. We get varying feedback from folks as to what connectors they like the best. And so when we can do both, we do. We have USB, that's to hook it up to your computer for control and configuration, and then the phone line and Ethernet. So yeah, that's, I think, mostly what I wanted to talk about. We have a lot of other products. The other one that I was going to mention is AES distribution amplifiers. We've been updating all of our distribution amplifiers, but our AES distribution amplifiers specifically, the AES DA 1x6, what we've added to those products are redundant power inputs. So if you lose a power supply, you can have a second power supply right there running. And then bypass relays. So the idea of a bypass relay is that if you lose power, input 1 will route to the output passively. So we've added that to the 1x6. And then we have a new one, which is the ESDA 2x4 1x8 term. And that's a configurable DA using terminal block connectors. And it's also got redundant power and bypass relays. So thanks for listening, and let's talk. If you got any questions, let me know.
Hey, Grady, I see your hands up.
Hi, Grady.
Grady?
I'm trying to unmute. Can you hear me now?
We most certainly can, thank you.
I would like to share my screen for a moment, if I may.
Okay. Go ahead.
Okay, I just tried to do it, and where is this? I guess I have to try again. Okay, here. I guess you can see that.
Yep.
I got a lot of radio stations that I do now, and a lot more I've done over the years, and I've had a lot of different remote control systems. But this, we built this 10 years ago. It's the WUMB Public Radio Network transmitter readings page. We started putting up more and more transmitter sites, and we needed to have a page that live announcers could just look at on a screen and know at a glance whether or not they had a problem anywhere. So I designed this screen when we only had 4 stations, and as we've built out more, we've added more. Everything that feeds this is a broadcast tools device. And any reading that is within the normal range is green. If there's one that's outside the normal range, it's red. If you see something that's wrong, all you have to do is click on the call letters, and it immediately, I don't know if you can see this, it should be sharing the same screen. It should just take you right to the login page for that particular remote control. And the interesting thing about this is, because of the hierarchical passwords that are a part of all the broadcast tools remote control devices, anybody who sees this screen can get in with the password and the username that they have been given. So announcers can only get in and take readings. And there are 2 or 3, however many levels of hierarchical passwords, you can get to them through that interface. So we're kind of happy about that. Recently, we bought a whole bunch of those Innovonic site streamers. And if you just click on this dot, it brings up the Innovonic site streamer. from the same page. So if there's a station that is showing that there might be some kind of problem, I can just go here and I can click on this and I can hear it. It'll actually let me hear it.
Band of Joy, Angel Dance, also.
So I'm pretty much married at the hip with the Broadcast Tools devices at this point because it does so many wonderful things. Now, this one, we're not using anything fancy, SNMP. We're just having the units. Each of these units sends an email once an hour that has the readings in it. It goes to a server that receives them. It scans them. It gets the data and puts it in the correct windows. Remote controls that have more than one channel, like Falmouth has a Site Sentinel 16. Unfortunately, the transmitter there has been replaced and doesn't have all those channels. We only did that last month, so we haven't reprogrammed it. But this is the kind of power that you can get. And this tells us that the readings were taken at 2 o'clock. And in 22 minutes, these will all update. If I want to get an update after I've made a change, all I have to do is go into this the Broadcast Tools box and go to the page where I can have it send a test email, and it will update these readings at that time so that I no longer have red stuff on the page after I've fixed a problem. I just thought you might like to see the kinds of things that the Broadcast Tools box let you do, because to a certain extent you can think of it functionally as almost an open source device. So let's see, can I stop sharing? Now I'm going to do that, and I'm done.
Hey, Ben, when we talk about SNMP, do you have charts, books of the various codes for various equipment that you would share with the user?
Right. Yeah. So we have MIB files, one for each product, that define all of the values that you can read from it and the controls that you can do. And typically, everything you see on that monitor control page that we looked at earlier in the presentation is available via SNMP. For example, the ability to control the relays or get the readings that Grady's getting via email. And then
if
also,
someone has a question, they can give you a call and you'll walk them through it.
right. Yeah. No, if you need that information, just shoot us an email and we will get that to you.
Excellent. Chris, I see your hand.
Yeah, just a quick question. I dialed in a little bit late here, so I might have just missed it. But on your silent sensing devices, is there a way to get those to trigger a source? For example, if you're out of gas and you want to turn on whether it's an MP3 player, a cassette player, something like that, is there any provision for that?
Yes. So a good example of that would be with the Audio Sentinel Plus Web for analog audio, which is a 2x1 silent sense switcher. It has the ability to automatically switch to backup audio. And when it does that, we also have programmable relays. So it has 2 programmable relay outputs. And so you can have it, for example, when silence is detected on input 1, provide a sustained closure or a pulse closure, but sustained closure is probably more useful. And that could trigger an audio playback device for sure.
Great, thank you.
Very good. Thank you. Harold.
Yeah, first off, these are very nice products. Great job. On SNMP and MIBs, in the products I designed that had SNMP, I just put the MIB as a web page internally in the firmware, so people could download it at any time, and it was always synchronized with the firmware version. So, suggestion.
That is a good idea. I've seen that in other products, not ours, but that is a good suggestion.
Okay. Any other questions or comments? You can press your space bar or alternate A to unlock your mic or raise your hand. Nice range of gear, Ben, and I can see several projects that I'd attack. The temperature is something that many transmitters have one internal temperature, but doesn't tell you what's in the building, or the fact that you could immediately start a second air conditioner or set off an email. Very good product there.
So I have a question, Ben, and that is when will the Alert Sentinel be ready?
So we are in the process of finishing the firmware. I think we've got pretty good hardware at this point, so it's going to be a few more months yet.
Because I know a station that was just dying for that piece of equipment.
Good. Yeah, we have a couple stations lined up already that want to test it. Yeah, that's what we've been hearing is that there is an application.
Very good. Any other thoughts?
So just on the subject of remote controls, like nowadays you can buy a transmitter with a lot of control functionality built in, and I think that's great. I think there's still room in the world for the standalone remote control, either in conjunction with a device that already has a built-in web interface or just completely separate from that. Typically nowadays with our customers, we kind of see two groups, the ones who are all in on SNMP. That's a lot of times the larger broadcasters. And so that's oftentimes all they're interested in is get this information into the SNMP manager and forget about the rest. And our products are totally capable of doing that. Then with the smaller broadcaster, they might not even know what SNMP is yet. Often it's a question I get a lot of the times when we're going through configuration and tech support call is, oh, what's that? And that's okay. Not everybody needs SNMP. And for those folks that don't, these remote controls work great as just standalone devices. We try to put everything you need in one box. And so that's just what I wanted to say.
Great. Well, Ben, thank you so much for coming and visiting with us today, and hope to have you back later. Maybe when these products get out in the field, the new ones, we could do a live demonstration or something like that.
Sure. Well, thanks a lot for having me.